When upgrading to a 400 amp electrical service, understanding the correct wire sizes and disconnect switch requirements is crucial. According to the National Electrical Code, specifically Article 225, a 400 amp service necessitates a minimum wire size of 4/0 American wire gauge aluminum or 3/0 American wire gauge copper for the run from the meter to the weatherhead. These values are minimums, so always double check with local codes and your power company. To purchase the appropriate disconnect switch boxes, visit your local electrical supply store or a home improvement center. When inquiring, specifically request main lug disconnect switches rated for 400 amps. This rating ensures the switches can handle the full capacity of your upgraded service. The wire running from the meter to the weatherhead, and subsequently from the weatherhead to the disconnect switches, must be protected by electrical conduit. Conduit provides a physical barrier against damage and environmental factors, ensuring the longevity and safety of the wiring. Proper grounding of the entire electrical system is absolutely essential and must adhere strictly to the National Electrical Code guidelines. Grounding provides a safe path for fault currents, minimizing the risk of electrical shock and equipment damage. A licensed electrician is highly encouraged to conduct a thorough inspection of the work before energizing the system. This inspection verifies that all connections are secure, wiring is correct, and the installation meets safety standards. While the power company will likely handle the meter and weatherhead installation, responsibility for installing the disconnect switches and wiring to the existing house and the new garage apartment falls to you or your chosen electrician. In summary, firstly, determine the correct wire size for the 400 amp service, remembering the National Electrical Code mandates a minimum of 4/0 American wire gauge aluminum or 3/0 American wire gauge copper from the meter to the weatherhead. Secondly, acquire main lug disconnect switches rated for 400 amps from a reputable electrical supply store. Thirdly, ensure all wiring is enclosed in electrical conduit for physical protection and compliance with safety regulations. Fourthly, implement proper grounding throughout the entire system, following the National Electrical Code guidelines to mitigate electrical hazards. Fifthly, arrange for a licensed electrician to inspect the completed installation prior to energization to confirm code compliance and safe operation. Remember, electrical work can be dangerous, and this information is provided as general guidance. Always consult with qualified professionals to ensure your safety and code compliance. In addition to wire sizing and disconnect switches, consider overcurrent protection. 400 amp service will require appropriately sized breakers or fuses to protect the wiring and equipment from overloads and short circuits. The National Electrical Code specifies the requirements for overcurrent protection based on the ampacity of the conductors. Also, consider the load calculations for both the existing house and the new garage apartment. The 400 amp service must be adequate to handle the combined loads of both buildings. This calculation involves determining the total amperage required for lighting, appliances, heating, cooling, and other electrical equipment. The power company may require these load calculations before upgrading the service. Furthermore, coordinate with the power company regarding the placement of the meter and disconnect switches. They may have specific requirements or preferences for the location of this equipment. This coordination ensures that the installation meets their standards and facilitates easy access for meter reading and maintenance. Don't forget the importance of using appropriate connectors and terminations for all wiring connections. These connectors must be rated for the wire size and material being used, and they must be properly installed to ensure a secure and reliable connection. Loose or improperly installed connectors can lead to overheating, voltage drops, and even electrical fires. Consider the impact of voltage drop on the performance of electrical equipment. Long wire runs can result in a significant voltage drop, which can reduce the efficiency of motors, lights, and other appliances. To minimize voltage drop, use larger wire sizes or shorten the length of the wire runs. The National Electrical Code provides guidelines for calculating voltage drop and selecting appropriate wire sizes. Ensure compliance with all applicable building codes and electrical codes. These codes vary depending on the location and may have specific requirements for electrical installations. Consult with local building officials to determine the applicable codes and obtain the necessary permits. Don't neglect the importance of labeling and identification. Clearly label all disconnect switches, circuit breakers, and other electrical components to facilitate troubleshooting and maintenance. This labeling helps to prevent accidental disconnections or energizations, which can be dangerous. Consider the use of surge protection devices to protect sensitive electronic equipment from voltage spikes and surges. These devices can be installed at the service entrance or at individual outlets to provide protection against lightning strikes, power surges, and other electrical disturbances. When working with electrical wiring, always disconnect the power at the main disconnect switch before beginning any work. This precaution minimizes the risk of electrical shock. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to further reduce the risk of injury. When running conduit, use appropriate bending and cutting tools to ensure clean and accurate installations. Improperly bent or cut conduit can create sharp edges that can damage wiring and pose a safety hazard. Securely fasten all conduit and wiring to prevent movement and vibration. This fastening helps to prevent damage to the wiring and ensures a reliable electrical connection. When making connections, use a torque wrench to tighten the connectors to the manufacturer's specified torque. This ensures a secure and reliable connection that will not loosen over time. After completing the electrical installation, thoroughly test all circuits and equipment to ensure proper operation. This testing helps to identify any potential problems or defects before the system is put into service. Always maintain a clean and organized work area to prevent accidents and ensure efficient work. Remove any debris or obstructions that could pose a tripping hazard or interfere with the electrical installation. When working in confined spaces, use appropriate ventilation to prevent the buildup of hazardous gases or fumes. Electrical equipment can generate heat and potentially release harmful substances, so adequate ventilation is essential. If you are not comfortable performing electrical work yourself, hire a licensed electrician to do the job. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to perform the work safely and correctly. A licensed electrician has the training and experience to ensure that the electrical installation meets all applicable codes and safety standards. Finally, always keep accurate records of the electrical installation, including wiring diagrams, load calculations, and inspection reports. These records can be helpful for future maintenance and troubleshooting. These records also provide documentation of the electrical system for insurance purposes. Remember, safety is paramount when working with electricity. Always follow safe work practices and consult with qualified professionals to ensure a safe and reliable electrical installation. Always turn off the power at the breaker before working on any electrical component. Use a non-contact voltage tester to verify that the power is off before touching any wires or terminals. Wear rubber gloves and safety glasses to protect yourself from electrical shock and arc flash. Never work on electrical equipment in wet or damp conditions. Water is a conductor of electricity, and working in wet conditions increases the risk of electrical shock. Avoid using metal tools when working on electrical equipment. Metal tools can conduct electricity and increase the risk of electrical shock. Use insulated tools specifically designed for electrical work. Do not overload electrical circuits. Overloading circuits can cause overheating, which can lead to electrical fires. Use appropriately sized breakers and fuses to protect circuits from overloads. Never tamper with or bypass safety devices, such as ground fault circuit interrupters. These devices are designed to protect people from electrical shock, and tampering with them can be dangerous. Inspect electrical cords and plugs regularly for damage. Replace damaged cords and plugs immediately to prevent electrical shock. Keep electrical equipment clean and free of dust and debris. Dust and debris can accumulate on electrical equipment and cause overheating. Do not run electrical cords under rugs or carpets. This can trap heat and cause a fire hazard. Use extension cords only temporarily. For permanent electrical connections, install additional outlets. Do not allow children to play with electrical outlets or cords. Cover unused outlets with safety caps to prevent children from inserting objects into them. If you experience any electrical problems, such as flickering lights, sparking outlets, or burning smells, contact a qualified electrician immediately. These problems could indicate a serious electrical hazard. Never attempt to repair electrical equipment yourself unless you are a qualified electrician. Electrical repair should be performed only by trained professionals. Follow all applicable electrical codes and regulations. Electrical codes and regulations are designed to ensure the safety of electrical installations. Consult with local building officials to determine the applicable codes and regulations. If you are unsure about any aspect of electrical work, consult with a qualified electrician. It is always better to be safe than sorry. Remember that electricity is a powerful force that can be dangerous if not handled properly. By following safe work practices and consulting with qualified professionals, you can ensure a safe and reliable electrical installation. In conclusion, upgrading to a 400 amp service requires careful planning and attention to detail. By following the guidelines outlined above and consulting with qualified professionals, you can ensure a safe and reliable electrical installation that meets your needs. The correct wire size is 4/0 American wire gauge aluminum or 3/0 American wire gauge copper. Purchase main lug disconnect switches rated for 400 amps. Use electrical conduit for protection and proper grounding as per the National Electrical Code. Remember to have it inspected before you energize your system.